Hi everyone, this is Kruti Jaipancholi, Assistant Professor in LJ Institute of Engineering and Technology in Department of Electronics and Communication. You are watching a lecture series of Microwave Engineering. In this video, we are going to discuss regarding analysis of microwave transmission line and waveguides. Particularly, you will learn about reflection coefficient calculations. So friends, what is the reflection coefficient? Here you can see that the VI the input voltage. Now the transmission line and it is connected at the another end via the load, that is the ZL. So towards the load, okay, the value is the V1 e raised to minus gamma Z, and toward the source this value is the V2 e raised to gamma Z. So we can write the reflection coefficient rho is equal to VR upon VI. So we'll put the value of this. It is equal to V2 e raised to gamma Z upon V1 e raised to minus gamma Z. We can rewrite it V2 by V1 e raised to gamma Z plus gamma Z. Okay, while it go from the denominator to numerator. So it is the e raised to 2 gamma Z. So we can write the rho is equal to V2 upon V1 e raised to 2 gamma Z. Over here you can say that the e raised to 2 gamma Z, that is the phase, and V2 by V1, that's the magnitude. So I can write the VL is equal to V1 e raised to minus gamma Z plus V2 e raised to gamma Z. So Iz is equal to 1 upon Z0 in bracket V1 e raised to minus gamma Z minus V2 e raised to gamma Z. So load impedance is equal to ZL is equal to VL upon IL. So now put the value of the VL and IL in the above equation. So it is ZL is equal to VL upon IL. It is equal to V1 e raised to minus gamma Z plus V2 e raised to gamma Z upon 1 upon Z0 V1 e raised to minus gamma Z minus V2 e raised to gamma Z. So this is equal to Z0 in bracket V1 e raised to minus gamma Z plus V2 e raised to gamma Z upon V1 e raised to minus gamma Z plus V2 e raised to gamma Z. So it is equal to Z0 in bracket 1 plus V2 upon V1 e raised to 2 gamma Z upon 1 minus V2 upon V1 e raised to 2 gamma Z. So now we know that the rho is equal to what? It is V2 upon V1 e raised to 2 gamma Z. Okay, so we can put the value of the rho in the above equation, and it is the ZL is equal to Z0 in bracket 1 plus rho upon 1 minus rho. So therefore ZL upon Z0 is equal to 1 plus rho upon 1 minus rho. So we can rewrite the equation, okay, by writing ZL in bracket 1 minus 0 is equal to Z0 in bracket 1 plus 0. Simplifying the equation, we can write ZL minus rho ZL is equal to Z0 plus rho Z0. So ZL minus Z0 is equal to rho Z0 plus rho ZL. So ZL minus Z0 is equal to, taking the rho common, it is ZL plus Z0. So this way we can write the equations by understanding the concepts, and we can put it into the formula, and we can write the rho is equal to ZL minus Z0 upon ZL plus Z0, where ZL is the load impedance, Z0 is what? It's a characteristics impedance. So rho is equal to ZL minus Z0 upon ZL plus Z0. So, now the condition that we need to put inside this, that if the load impedance and the characteristics impedance both are same, mean if the ZL is equal to Z0, then load impedance is equal to the characteristics impedance. So magnitude of the rho is equal to 0. So if the magnitude of the rho is 0 in the reflection coefficient value, if it is 0, then there is no refraction. Okay, and if the ZL is not equal to Z0, then the reflection that will occur. So we can have the idea of the reflection coefficient, and if you want to say about something related to the reflection coefficient, then you must know about it, that if the load impedance, okay, and the characteristics impedance value, that plays a big role. So if the ZL is not equal to Z0, then the reflection that would occur. Next is about the transmission coefficient. What is the transmission coefficient? So now here we are considering the diagram. In that, the Z0, that is the input impedance, ZL is the load impedance connected at the load end. The distance, okay, or the length of this transmission line, that is the L. The value towards the load is the V1 e raised to minus gamma L, and the value towards the source, it's a V2 e raised to gamma L. So transmitted signal is equal to V1 e raised to minus gamma L minus V2 e raised to gamma L. Incident signal is what? V1 e raised to minus gamma L. So now the transmitted signal is what? So it is equal to the transmitted signal divided by the incident signal. So we are putting that value inside the equation, and it is V1 e raised to minus gamma L minus V2 e raised to gamma L upon V1 e raised to minus gamma L. V1 e raised to minus gamma L upon V1 e raised to minus gamma L cancel. So it is 1 minus V2 upon V1 e raised to gamma L plus gamma L. It is 2 gamma L. But the rho is equal to what? It is V2 upon V1 e raised to 2 gamma L. So transmission coefficient is what? So it's now we are using the value of the rho. It is ZL minus Z0 upon ZL plus Z0. So now therefore it is the 1 minus ZL minus Z0, okay, upon ZL plus Z0. Okay, we are doing it. So it is what? ZL plus Z0 minus ZL plus Z0 upon ZL plus Z0. So transmission coefficient is 2Z0 upon ZL plus Z0. So this is about the reflection coefficient and the transmission coefficient. Now we will solve the examples based on this theory. So it is a sorted transmission line has a characteristics impedance of 75 plus j 0.01 ohm and is terminated in a load impedance of 70 plus 50 j ohm. So compute a reflection coefficient and the transmission coefficient. Now the data given that we can write. So it is the Z0 is equal to 75 plus j 0.01 ohm and ZL is equal to 70 plus 50 j ohm. Now reflection coefficient is what? So it's a rho is equal to ZL minus Z0 upon ZL plus Z0. So by putting the value, it is 70 plus j50 minus 75 plus j0.01 upon 70 plus j50 plus 75 plus j0.01. So it is equal to minus 5 plus 49.99 j upon 145 plus 50.01 j. So by converting them from the rectangular to the polar, we can write it as 50.23 angle 95.71 upon 153.38 angle 19.02. So it is 50.23 upon 153.38 and it is an angle is 95 minus 71 minus 19.02. So our answer is 0.33 angle 76.68 degree. By converting them from the polar to the rectangular, it is 0.08 plus j 0.32. So now the transmission constant, the tau, that is equal to 2z0 upon zl plus z0. So we can put that value in this and it is equal to 2 in bracket 70 plus j50 upon 70 plus j50 plus 75 plus j 0.01. So by converting them from the rectangular to polar, it is 172.505 angle 35.54 degree upon 153.38 angle 19.03 degree. So we can write, okay, the answer, it is a 1.12 angle 16.51 degree and we can have the answer 1.01 plus j 0.53. Okay, so this way we can solve the program, we can solve the examples as well as we can write all these programs in the MATLAB or the SCI lab, or you can do the C programming to solve about this. Okay, so that makes the task easier for us, okay, for writing all this thing. So this is about the transmission coefficient, okay, reflection coefficient. So by considering all the points in the mind, we can further design the transmission line. Okay, so keep watching LJIET Electronics and Communication. So thank you very much everyone.